It is such an honor to present you our study on low-energy building, which is Pre-Environmental Center by architect Berlin Swiss Jackson. This study was proudly done by ANSON and SAMMI. This video will mainly introduce you to the multiple design strategies that have been integrated in the built environment that connects with nature, reducing the side effects on the environment while ensuring it is human-centric. Known as Living Building Certification (LEED Platinum), the Pre-Environmental Center is the world's first publicly accessible pre-emission living building challenge targeted project by architect Berlin Swiss Jackson. Fully utilizing the natural resources on site has helped it achieve an energy surplus and has net zero effect on the environment. Located in Pittsburgh, United States, the center was completed in the year 2016 with a site size approximately 15,570 square feet. Looking into the sun part of the site, the building is in a north-south orientation, and the prevailing wind is from the southwest direction. The building is located in the edge of a south-facing slope. The passive insulation of the Pre-Environmental Center is added at the south facade, which is full with big windows and desks. Surrounded by wetlands, woodlands in front of the facade also help to maintain cooler temperature in the building. We have identified several strategies that taking advantages of the natural resources in reducing the energy consumption on site. Without further ado, this is our first identified strategy, which is solar energy. The Pre-Environmental Center is mainly powered by installing photovoltaic that shade the parking lot. The solar panels are estimated to provide roughly 15,000 kWh of energy per year, which is about 10,000 kWh more than the facility will consume. The surplus will then be returned to the electricity grid. This leads me to my next point, which is energy conservation. The Pre-Environmental Center is being controlled and monitored under automated device in its energy-related system. Water heater at the point of use as well as daylight and occupancy sensor ensure that the building only uses electricity when it is needed. Outdoor lights consist of pole-mounted LED lights and bulbs for low-level lighting, while interior lighting uses highly efficient fluorescent and LED lights. Furthermore, the weather conditions outside the facility are detected by red-green light system. When the conditions are ideal, the green light will turn on and signaling the user to open the windows and enjoy the pleasant weather. If you look at this diagram, you will see the natural ventilation is designed successfully to enable smooth air flow within the structure. Cool air enters the building through the lower floors and circulates throughout the structure. The air will then exit through the motorized skylight, creating a stack effect. The building is positioned in a way to take in as much of the prevailing winds in Pittsburgh as possible to promote natural ventilation during the summer. When cool winds is unwanted, the user can just close the open-level windows to prevent heat loss. Now we come to the next point, which is building materials. The primary regenerative resources products used in this building are as the following, which is steel, concrete, stone, aluminum, and black locust wood. The black locust wood is known as dense, durable, and resistant building material used in constructing Pre-Environmental Center. Black locust wood is naturally rot-resistant and has anti-fungal properties. It is a hardwood that keeps its attractive appearance without the help of chemicals or oils. When looked at the Pre-Environmental Center, the curtain wood is largely composed of locally harvested black locust wood panels and full-height trim of glazed glass. Besides, the building has a light-colored aluminum roofing, which is designed to prevent the direct summer sun to reach into the building spaces, reducing heat gain, while also allowing the sunlight to penetrate during the winter to increase internal heat. Aluminum known as high solar reflectance index material, which can reduce the heat island effect. I would like to move on the geothermal system that implemented on site. The earth can be used as either a heat source or heat sink in a geothermal system. Providing for the flood in the geothermal system in Pre-Environmental Center, which is an antifreeze or refrigerant. During the cool season, the geothermal heat pump will absorb heat from the earth and use it for radial flow heating in the environmental center, while in the summer, the cooler will absorb heat from the building and releasing it into the earth. Now we come to the next point, which is rainwater harvesting. The center is built to gather and store enough rainwater to cover all of its potable and non-potable water needs. Rainwater is stored in a 15,000-gallon underground tank collected by the big water area canopies and passing it through above-grade rain barriers. Before being used across the site, the rainwater is treated in a 3-stages process that includes a 5-micron stainless steel filter and 2 UV treatment units.
Alright, now we will move on to the 3-phase cooling strategy of the Frick Environmental Center, which is our main focus. The first phase is passive natural. It uses natural ventilation coming through the windows at the south facade when the outdoor temperature and humidity is suitable. This is normally between 15 and 26 degrees Celsius. There's also a green light system which indicates when occupants should open the operable windows, and it also triggers automatic windows throughout the building to be opened or closed. Red lights indicate that the weather condition outside is poor and windows should be kept closed, while green lights indicate that windows should be opened to cool the building and save energy. The second phase is active natural. When additional air exchange is needed because of high amounts of CO2, mechanical fans will turn on automatically and air is exhausted at the top of the stair tower through stack ventilation, and at the outdoor classroom with an exhaust fan. Fresh air will come in through the operable windows at the south facade. The third phase will be mechanical and energy recovery. An energy recovery ventilation system, ERV, is used when the outdoor conditions are not suitable for natural ventilation. An enthalpy wheel will be used here. Instead of just exhausting the air that has already been circulated throughout the building, the heat in the air can be reused in the winter, or it can also be a heat sink in the summer to either pre-warm or pre-cool the intake air. Therefore, the machines do not have to work as hard to cool or heat the interior spaces. It allows for both heat energy and moisture to be exchanged to achieve thermal comfort in the building. At night, the building will flush by taking outside air in and allowing hot air to escape via stack ventilation to precondition the building. The environmental center has 11 different zones which can be individually heated and cooled, keeping energy from being wasted on empty rooms. Next up will be the post-occupancy evaluations. The post-occupancy evaluation surveys found that overall employee happiness, comfort, and productivity have increased because of the temperature, ventilation, and humidity regulation. The working area has been changed to help facilitate collaboration and social interaction, and employees agree that they do not only feel more collaborative, but also more creative and relaxed. In brief, the building has become a space where building occupants feel healthier and happier overall. Thank you for listening to our presentation, and we hope that you have learned a lot about this building.